Welcome back, sixth grade. We're going to keep talking about percents today, and we're going to talk about percents we've seen in science. So hopefully that'll help make percents more clear and more practical for you. Let's go ahead and make this the title of your next free page in your math notebook. When you've done that, close it up. Give me lots of concentration and focus, and then you'll write when we get to we do. So we've been talking percents. We've talked about problems like, can make up on the spot here. Maybe someone earns $40,000 a year, and they pay 20% in taxes. How much do they pay in taxes? And that's the kind of problem we've been looking to do. So remember, a percent is a special type of part. Came out funny. Part to whole ratio, where the whole is out of 100. So we make it out of 100. So here, if we say 20%, that means 20 out of every $100 they make is paid in taxes. So if they made $100, they'd pay 20. If they made $200, they'd pay 40. If they made $300, they'd pay 60, and so on. 20 out of every 100, in this case, is the taxes. That's what 20% means. So that is a part. Oops, sorry, I'm having a lot of trouble with my, if you'll notice, I'm sure you will, having a lot of trouble with my program and my pen today, so I may have some issues. So that's a part to whole ratio. And so we've got this $40,000 per year. That's a whole. That's how much money this person makes. And we want to know the part that they pay in taxes. So we have a part here and a whole here as well. So we want to know what part of their 40,000 goes to taxes. So 100 times what is 40,000? So 100 times 4 is 400, times 40 is 4,000, so times 400 would make time 40,000. So we would also do times 400 up here and find out that that was 8, 1, 2, 3 zeros. So this person would pay $8,000 of their money in taxes and keep the other 32,000. So that's just a quick refresher of how percents work in ways we've done so far. So let's look at some science-related problems to them. This one's, I saved this one for I do because there's a lot to do with it. So here we go. Georgia Power can generate the following amounts of electricity each year from different sources. What percent of the electricity they can generate does not release greenhouse gas? What percent of that electricity does not release greenhouse gas? Well, if you'll remember back, I don't know why they separated hydro and renewables, because hydro is a type of renewable. But obviously those two would not release greenhouse gas. Also, nuclear, while not, it's not renewable, it is clean. It does not release greenhouse gas either. So it looks like out of all the electricity they can make, this much of it would be clean or would not release greenhouse gas. We can figure that out. So just to make this problem a little easier with these really large numbers to get the percent, I'm going to round these off to maybe the nearest 100,000. So I'm going to say like that is about 6 3/10 million. Whoops, see, I'm telling you I have a problem with my pen. So we'll say that's just 6.3 million. Oh, 6 3/10 million. And that is 4 8/10 million if I round it. That is rounds up to 2 million. This is what happens all the time with it. It wants to make these long streaks on my 2. 2 million. This is about 1 1/10 million. And this one's about 0 2/10 million. So if I just round those all to the nearest million, I'm going to get some numbers close to that. All right, so that's all just rounding. So remember, what I want to know is what percent of all this electricity would not release greenhouse gas. So that's what I want to know. So remember, a percent is a part to whole ratio. So I'm going to need parts and wholes. So the first thing I'm probably going to need to know is how much is all this added up. I think I'm just going to go ahead and use a calculator to do that quickly. That's not really so hard to add, but I'll make sure I'm accurate here. 6 3/10, 4 8/10, 2, 1 1/10, and 2/10. So altogether, if I add those up, I get something around 13 4/10 million kilowatt hours of electricity. That's the unit electricity is made in. My thing is disappearing on me. Kilowatts is the unit. So out of all, so that's my whole. Altogether, we can make 13 4/10 million kilowatts of electricity. So what's the part that's clean? That is these ones here. That's 2, 3 1/10. That looks to me like 3 3/10 out of the 13 4/10 that they can make are clean. So I add those up. 3 3/10 out of the 13 4/10 are clean. Oh, sorry about that. So much drama with my program today. I apologize. Well, now it's not erasing that, it's erasing everything else. So I'm just going to put it back and we'll just live with it. So sorry for the big streak across the page. So we want to know, knowing that then, what percent is that out of 100? So if we had 100 of these, sorry for all this, what would we get? So what would I multiply 13 4/10 by to get 100? Let's figure that out. 100 divided by 13 4/10. Just hope I make it through this one without my whole program crashing. Is about 7.5, a little less than 7.5. 7 4600ths. So we're also going to multiply that up here. And we'll figure it out. So if 3 3/10 out of 13 4/10, what percent is that? We just multiply our numerator by the same, which I'm going to do. So 3 3/10 times 7 4600ths tells us that about 24% is renewable. So not a whole lot, actually. If you look at those numbers too, obviously way more of it comes from those top two categories, which are fossil fuels to begin with. So it's really not a big percent. It's about 24%. Okay, in order to avoid some drama, I'm going to ask you to open your notebook for redo. I'm going to put the question up so that you can start copying it down. There's a lot of info on there. As far as this power bill goes, you don't need to copy the whole power bill. You really just need this. This is how many kilowatt hours I used on my bill, if you remember from back when I showed you this. I'm going to transfer all this over as you pause and write this down. I'm going to transfer this over to another source in the hope that we get through the problem without my whole program crashing. All right, let's see if this works a bit better. We'll hope for the best. So here we go. So I used 387 kilowatt hours of electricity in the month that I'm showing you this bill. It was June of 20 to July of 20. So that's how much I use. That unit kWh, that's just the unit that's used to make electricity. It's the unit that it's measured in. So my question here is, how many of those kilowatt hours came from renewable energy sources? All right, so we're going to get into some science here, right? So on this chart, I've got renewable here in its own thing. Let me switch colors. So this is renewable. That must be a combo. And hydro, I'm not sure why they separated hydro out from the other renewables, but it's obviously renewable as well. So it looks like in all, out of everything, 6% of my electricity comes from renewable energy sources. That is not much. 6 out of every 100 kilowatt hours. So that's like if I used 100, 6 would be renewable. If I used 200, 12 would be renewable. Pretty pitiful, frankly. So what I really want to know, if I use this much energy, how much is renewable? Not much, right? So I used 387 kilowatt hours. So that is times 3 and 87 hundredths to get there. 100 times 3 and 87 hundredths. So I would multiply that by 3 and 87 hundredths. And it's really not going to be much. What it's going to be between 18 and 24, 6 times 3 and 6 times 4. Pretty pitiful amount when I go back and calculate it. 6 times 3 and 87 hundredths. So you got 23 and a little. So not much. Unfortunately, far less of our electricity is renewable than I would wish. So that's percents have come up a lot in science, and I just wanted to kind of go back now that you understood how the math worked and really talk through some of these science percentages that you've already seen. So I hope that helps make a little more sense of it and helps percent seem relevant and important to you. Once you've got your we do written down and understand it, if you feel like you need to go back and look at either example again, please do. If not, you are all set, and I'll see you in class.